Talk to your neighbors. Okay, so again, quiz problem 1. Find n is a thing that we're doing over and over again, fixed number of times. What are we doing over and over again? Drawing a marble. Perfect. So then look at one single draw of the marble. What am I asking myself about the marble?
Is it red?
Yeah. Are you red or not? That's what I'm asking. What's the probability that I draw that marble and it's red?
0.3.
Yeah, 0.3. Why?
3 out of 10.
3 out of 10 marbles. Everybody all right that part? So 3 out of 10 marbles. My little p is 3 out of 10. Which means that my little q is what?
0.7.
Yeah, 0.7. Good? Okay. All right. Now I can do kind of the rest of these pieces. Now I can look at what else we have, which is, finding the probability that x is exactly 2. So I know my n, I know my p. What's my x? And again, remember, n and p for any binomial distribution, those are fixed. We use it to find our mean, our variance, standard deviation. What varies is my x. My x can be, that's my variable, right? The variable is x because it varies anywhere from 0 successes to 12 successes, right? 0 to n successes. So this is the thing that varies. In this case, I want to know what's probably that x happens to be 2. Right? Because that's the thing I can find the probability. I can't find the probability that n is 12, because that's 100%. Right? N is 12. It is. It doesn't vary. Does everyone see what I'm saying? I want to find the probability that x is 2. Sometimes it's 2, sometimes it's not. What's the probability that it is 2? All right, so that, again, is binomial n choose x times little p to the x times little q to the n minus x. I'll give you guys a couple minutes to work on that while I tell the people at home, remind them of the things that we talked about last class earlier that I skipped. So take a minute with your neighbors and work on that. So again, these are the things we're working on today. We have our exam coming up a week from Thursday. I'm going to do a review session on Wednesday from 6:30 to 8 in room 601. And this is the information for exam 2. No calculator or a very basic calculator that can just do addition, subtraction, multiplication, and division, and maybe square roots, but basic calculator. And then the binomial distribution is really good. It depends just on n and p. And the mean and variance are really easy to find. Mean is np, variance is npq, and standard deviation is square root of npq. So that leads us to this part here. So, what did you guys get? All right, so the probability that x is 2 is 12 choose 2, yes, times what? 0.3 to the
2.
second, great, times 0.7 to the 10th. Yep, because if I have 2 successes, I must have 10 failures, because I have 12 altogether. 2 successes must be 10 failures. Good. And then you do all that, and you guys got what?
0.168.
168?
Yeah.
Okay, great. Perfect. Then find the mean and standard deviation. So again, my mean is NP. So that's going to be 0.3 times 12, 3.6. And then my standard deviation is going to be the square root of NPQ. So it's going to be the square root of 3.6 times 0.7. And what did you guys get for that? 1.59. Good. 1.59 or 1.6, I don't care. Either one's fine. Do you guys need 15 seconds with your neighbors on this? No? Really, really, really try not to miss class. I know people are getting sick, and I know that colds are going around. But, wash your hands a lot. Get a lot of rest. Drink water. Don't share utensils with other people. Stuff like that. Okay. Z values, z-scores. Allie, go ahead and read.
A z-score represents the number of standard deviations that are
Good. Right, so again, a z-score is how many standard deviations is your value away from the mean. Your x value. It's your weight or your height or your whatever it is you're talking about. Your class score. How many standard deviations away from the mean is that? That's your z value. How do you find it? Take your x value, you figure out how far you are from the mean. You take your value, subtract the mean. If you're above the mean, it should be positive. If you're below the mean, it should be negative. So find out how far you are from the mean, and then divide that by standard deviation. Gives it to you in standard deviations. That's your z-score. Don't tell me I didn't even start this. Oh, I did.
Is this the only class that you record?
No, I include the net class too. But the thing is that if I don't record this class, and that because I messed up in the beginning, and then I screw up that class, then I have nothing, right? So I have to at least record this class, and then take the one that's least screwed up. Or sometimes try to parse them together, right? And you figure the first part of this is screwed up, the second part that's, so it kind of works. All right, so remember, binomial depends upon two things, n and p, right? Normal distributions depend upon two things, your mean and your standard deviation. That determines everything you need, your position, your shape. Your position is your mean. In other words, where are you on the scale? And your shape is, are you squint? Here, I'll show you what I'm talking about. Right, so the mean kind of says, where is it centered? Where is this kind of hill centered? And then the standard deviation says, is the hill a really wide, flat hill, or is it kind of scrunched up, tall hill, right? How spread out is it? Remember, if I take two samples that have the same distribution around their mean, will have the same standard deviation. So here, see these numbers? They have a standard deviation of 4.1. If I add 2 to every one of those numbers, right, add 6 plus 2, 7 plus 2, 9 plus 2, 12 plus 2, then these numbers will also have a standard deviation of 4.1. All we do is shift all of them up 2. So their shape stays the same. The only thing that's changed is their mean, their average. So since their shape is the same, their standard deviation is the same. Let me show you what I'm talking about. Look at these numbers, 1, 2, 3, 4, 5. They have a mean of 3. Everybody agree with that? Now I'm going to add 2 to every single one of them. If I add 2 to every single one, that becomes 3, that becomes 4, that becomes 5, that becomes 6, that becomes 7. These have a mean of 5. Everybody on board with that part? Now, how do we go about finding the standard deviation? I find out how far each one is from the mean, right? X minus x bar. You guys remember that part? So how far is this from the mean? -2, -1. That's right on the mean. That's 1 above. That's 2 above. Yeah? You guys remember this? It's going to happen for the exam. And then we square those values. X minus x bar squared. -2 squared is 4. -1 squared is 1. 0, 1, and 4. And remember, the last thing we do for the standard deviation is we kind of average it. It's a sample, since it's a sample, you sort of average it, you add it up, and you get purple here, and divide by n minus 1. So add them up, divide by n minus 1. And if we add those up, we'd end up getting 10, n is 5, there's 5 of them, so divided by 4. Okay, good. Now let's look at the bottom one. Same thing. How far is each one of these from 5? This is 2 below, 1 below, right on it, 1 above, 2 above. But wait, look. Look at these numbers there. And those numbers there. They are exactly the same. Does everyone understand what I'm saying? So when I do the rest of the steps, square them all, and then add them up and divide by n minus 1, I'm going to get the exact same number. Right? So you guys, you know what I'm saying? If the stuff in green there and stuff in green there, they're the exact same numbers. So if I do the rest of the steps to them, I'll get the same result. Because that standard deviation is exactly the same as that standard deviation. How far they are away from their mean is exactly the same. Because all of them have gotten shifted. Right? They've all moved together. Right? So this is all of them. Here's our number line. Here's 1, 2, 3, 4, and 5. And all I've done is I've taken them and I've just moved them up 2. Their standard deviation is still the same. Their average is still the same. Their average has gone from here to there, but how far they are from their mean is the same. Okay, good. I'm not going to worry so much about this part so much as I kind of want to make sure you guys remember that if you get a problem on the homework or on the exam that says using the empirical rule or says approximate, that means that you should be using this 68, 95, 99.7% rule, which means that 68% of your data is going to lie within 1 standard deviation, 95% of your data is going to lie within 2 standard deviations, and 99.7% of your data is going to lie within 3 standard deviations. Right, so, and only use this when it says approximate or using the empirical rule. Those are the 2 things. Those are the 2 clues for that. Otherwise, we'd use our normal CDF like we learned last class. This applies only to normal distributions, so that will be in the prompt as well. What else about normal distributions? You guys remember that all the data, if I add up all the area underneath the curve, it would add up to what? 1, or 100%. Good. So if I want to know, so how many people have a z-score less than 0? 50%? Good. And we kind of know, like, we can use that empirical rule kind of for all these ones that land on an actual number of standard deviations. But what if somebody was like 64 inches? So they're here, or somewhere in this spot. We can't say, right, exactly what this probability over here is. However, what we can do is convert that to a z-score, and then the nice thing about it is someone has gone through and calculated all the possibilities for z-scores, a z-score down to 2 decimal places. So a z-score of 1.63. They know the area below a z-score of 1.63. They found all of those. And it's all stored in your handy-dandy calculator, right? So all of that it's in a table. We have tables as well, but it's also stored in your calculator. So all you have to do is use normal CDF to find those areas, which was kind of one of the last things we did last class. How do you do that? Normal CDF of the left z-score, comma, the right z-score. And this is what we mean by that. Everyone look up. This is your left z-score, this is your right z-score. All right, so find your shaded area that you're going between. This one's the left, that one's the right. If it goes here on up to infinity, that means an infinity is your right z-score. This is all kind of review of last class. And we kind of did this one last class too, if you guys remember. I'll just kind of go through it quickly again just in case people forgot. The first thing I want you to do, everybody pay attention because I need you to do these steps. Draw a picture. On the exam, these pictures are worth points. If you don't draw your pictures, you're going to lose points. So draw your hill, line down, and then tiny notch in the middle where your mean is. Then put in what z-score you want. So here I want the right of negative 1.14. Is that on the left or the right?
Left.
Left. So somewhere on the left, put that one in, negative 1.14. And then draw a line up. And I want to the right of it. That means to the right. That means this side. Which means my right z-score is going to be somewhere over here. So maybe draw a line out and put one in over there. So what's this z-score way, way, way over here? What is it? What's the z-score way over there? Infinity. However, you can just use any large number. What's your grandmother's age? 90. Perfect. You can use your age too, because all of you are old enough that your z-score is really huge in terms of probabilities. All you gotta do is be larger than 10. So just some large number, that's fine. So then normal CDF of negative 1.14 to 999, or just use any large number. The reason why I kind of let you use any large numbers is because people have a tendency to want to put a decimal place in here, and that creates all sorts of havoc, and it's completely wrong. So pick a large number, pick your age, pick your grandmother's age, pick somebody's age that's not a toddler, and you'll be in good shape. So if I do normal CDF of negative 1.14, comma 90, I'll get 0.8729. That means that 87.29% of the population, because this represents the whole population, that percent of the population has a z-score larger than negative 1.14. In other words, this area here is equal to 87.29% of the population. All right, so let's take a look at this one. Probability that z is greater than 1.98. That's the same thing as z is greater than or equal to 1.98. Why is that? Do you guys see the difference? How this one has an equal sign, greater than equal to, this one's just greater than? Because what's the probability that you have a z-score of exactly 1.98? What's the probability that this piece of paper is exactly 11 inches? Exactly 11 inches. Exactly 11. Anybody? You guys remember that from the first week of class? Anyone? Bueller? Billy? No? The probability this sheet is exactly 11 inches? The probability that it's 0. It's always going to be 1/1,000,000th larger or 1,000th shorter or something. It's never going to be exactly 11 inches. You guys remember that from continuous data? The probability that something is exactly something is 0. So this is continuous. Normal distributions are continuous data. The probability that your z-score is exactly 1.98 is 0. If you really went down to the very, very finest degree of fineness. So that's why it doesn't matter whether it's greater than or greater than or equal to, because this right here, or think of it as an area. This is a line. What's an area of a line? 0. It has no width. Okay, so this amount to up is what we're looking for. So I'm going to do, what's my left z-score? Guys, what's the left z-score of this area, this shaded area? 1.98. What's the right z-score? Infinity. Perfect. So I'm going to do normal CDF of 1.98, comma your grandmother's age, insert your grandmother's age.
90.
90, perfect. And you'll get, do it, find it. Calculator, grab your calculator and find it. Oh, I'm sorry. Let me give you the directions. So,
0.23.
yep. So you go to second, bars. I don't know if you guys can see this. Clear? So second, maybe I should stand in front of it this way. Oh no, I just removed it. Second, vars, and then down to normal CDF. Not PDF, CDF. And then you're going to put in, was it 1.98? Comma, which is above the 7. Infinity, your grandmother's number, I don't know, 91, 99, 98, sure. Enter. So you guys should get 0.2385. Rounded 0.00239. So generally speaking, z-scores we do to 2 decimal places. Areas we do to 4 decimal places. It's just, that's how the tables work, so that's, we just kind of fall in line with that. What does that mean? It means the probability that if I randomly pick somebody, the probability that their z-score will be larger than 1.98 is 2.39%. So in other words, I'm looking at heights. I grab somebody, if I randomly pick somebody, the probability that their height is in the upper, their z-score of their height is more than 1.98 is 2.39%. All right, so again, here are the directions if you need it. You guys want me to show you on the screen with the computer? Yes, no? All right, so turn on your calculator, and you're gonna do second, bars, and then down to normal CDF. And then you're going to put in whatever the left side z-score is. So in this case, it was 1.98. Commas above the 7. And then some large number. I don't know, 85. That's big. And there you go. If you have a fancy calculator, then yours might, let me see if I can do, if I can pull up a fancy one.
You just keep hitting enter.
Yeah.
If you have
So second bars, normal CDF. No. All right. So if you have a fancy calculator, then you're going to get, it prompts you for lower and upper. So type the lower one in the lower, the left one, and then arrow down, and then put the upper one, the right one in the upper, and then your mean needs to be 0. Your standard deviation needs to be 1. And then hit calculate, and then you have to hit it twice, I think. Right? So I think it's what RV just said. Okay, good. So here's your quiz problem number 2. Find the area under this curve. So here you're going to draw a little picture. If you didn't draw a picture, draw it now. Draw your little hill on your quiz. Draw your hill on your quiz. Right? So physically on your quiz, just draw this little hill and then put the ground going across it. And then put a little notch right in the middle. Tiny notch right in the middle. Then, you're going to put, just put a notch, not the whole thing. It's confusing later. And then, what are my z-scores? Negative 2.3 and positive 2.3. Negative 2.3 should be on the left side or the right side? So, somewhere over here. Positive 2.3 is somewhere over here. And draw your line up. Then you're going to shade between them. You have to shade. Okay. If you don't shade, then you're going to take off half a point somewhere along the way, right? So just you got to shade between them. I didn't know what area you're talking about. Okay, so now you have it shaded. I'll shade it nicer because I have it. I can. And then, what are my two z-scores? This is on, yeah, that's on the left. That's on the right. Do you guys see that part there? And the reason why I tell you guys to don't put some of the book things show one at 0, but then people get confused with 0 and they start going just to 0. So that's why I don't just put a notch at 0 because it'll start throwing people off and they'll start doing weird things in places. All right, so then we're going to do normal CDF. What?
Negative 2.3, comma 2.3.
Great, everybody do it. Find it. Find it.
0.9786. 97.
Everybody actually do it. Has everybody actually done it already?
Yeah.
97 what?
6.
86. So that means at 97.86%. Now, the reason I want you guys to do it is because some of you will get an error when you do it. And what happens is you put minus 2.3 in here. You can't do minus. Thank you. What you have to do is, there's this little tiny, in parentheses, a little negative sign here at the bottom next to the enter key. That's your negative sign for your to indicate a negative number. You can't use the subtraction sign or else it'll give you an error. So make sure you use that one. So you guys, let's do one more together. Probability that z is less than. Less than means left. Again, if you guys aren't familiar with this, it goes back to Nemo. Right? Here's a little fishy. He ate the smaller one. The big one is harder to catch, right? So it means the 1.73 is harder to catch. He's the bigger one. The z is the smaller one because he already ate him. That's the easiest way for me. That's how I kind of learned to tell the difference between which direction, which one's smaller and which one's larger. Okay. So this means z is less than 1.73. So here's 1.73 and z is less than it. It's on this side over here. The less than side. So what's my left z-score?
Negative?
Is this on the left side or the right side? So here's one side. What's the bottom side of this shaded area?
Negative 1.
You're way over here. Do you guys see what I'm saying? So what's this? It's negative infinity. That's the hard part. You guys, that's the key. You've got to figure out what's over here. If it's way over here, then it's negative infinity. If it's way over here, it's what? Positive infinity. Yeah, so go ahead and give yourself a little marker and stick it in if you need to, if it goes out this way. So you can kind of see, oh look, the shaded side on the left side, the lower one is negative infinity. The upper one is 1.73. That's where it ends. So think about where the shaded end starts and where it ends as you go this way. So this is the beginning one. Negative infinity, just use any large negative number. All right, so my left z-score is what, guys? Anyone?
Infinity.
Almost.
Negative.
Negative infinity. Right z-score is what? 1.73. So I'm going to do normal CDF of, what did you say earlier? Almost? Negative 90, comma, what do you guys think?
1.73.
Did you guys do it yet?
Yes.
Do it.
Yes.
Negative 0.958.
What'd you get?
Negative 0.958.
Okay. So here's the deal. If you get a negative number here, it's because you put this one in first and that one in second. So it's saying area for me. So that means you switched your left and your right. So if you did that, just be aware that it's going to give you a negative area. Can you ever have a negative probability or a negative area? No. So just kind of be aware of that, yes.
So on the exam, when we ask this,
Uh-huh.
if let's say the question was this itself.
Yes.
We can just put negative 30, right? Like if I use I would just put that as my left.
So
square.
I would like this to be negative infinity,
Okay.
but in here you can put in any negative number you want.
Okay. Thank
Yeah.
you.
Okay. So then what's the probability that z is less than 1.73? 0.95. Give me 4 decimal places.
0.82.
82, 81 or 82?
2.
82. What does that mean in words? Anybody? What does that mean in words?
95.82%.
95.82%
That is greater than,
of the population will what?
so the probability would be greater than 95% would be greater.
Well, no, 95.82% of the population will be what?
Smaller.
Will be smaller than what?
1.73.
Yeah, we'll have a z-score smaller than 1.73. Everybody okay with that part? Okay. So go ahead and do lab problem number 1. Lab problem number 1 has A, B, and C. First thing, draw a picture.